This is the question we're really starting with this year. What is science? Not just a definition you memorize, not just a subject you pass, but what science actually is and how it works. Over the next few minutes, I want you to think about science less like a list of facts and more like a process. In science, we do things like asking, why did that happen? What exactly happened? How can I make it happen again? When will it happen? If you have something that's going kind of slowly. Studying science is a lot like solving a puzzle. As you do more experiments, you get more and more bits of information, more pieces of the puzzle. Even when it seems as though there are enough pieces for you to actually kind of guess what the big picture is, the really nice thing, the marvelous thing about science is that you are never done finding new information. There is always new things to learn. And so while you might say, well, I know what this is, we actually find out that the big picture is just a little bit different than what we expected. All right, so that was science in general. Now let's look into chemistry a little bit more specifically. So ask yourself, what is chemistry all about? Now, if you've ever looked into a chemistry textbook, you will see that the standard definition is that chemistry is the study of matter and the changes it undergoes. Now, I have been studying chemistry and learning everything I can about chemistry for decades. And if this was all there was to it, I probably would have given up a long time ago. So I found an anecdote written by a very famous polymer chemist, Ira Remsen, and he gives a much better description of what chemistry is really all about. So while reading a textbook of chemistry, I came upon the statement, nitric acid acts upon copper. I was getting tired of reading such absurd stuff, and I was determined to see what this meant. Copper was more or less familiar to me, for copper cents were then in use. I had seen a bottle marked nitric acid on a table in the doctor's office where I was then doing time. I did not know its peculiarities, but the spirit of adventure was upon me. Having nitric acid and copper, I had only learned what the words act upon meant. The statement nitric acid acts upon copper would be more than mere words. All was still. In the interest of knowledge, I was even willing to sacrifice one of the few copper cents then in my possession. I put one of them on the table, opened the bottle marked nitric acid, poured some of the liquid on the copper, and prepared to make an observation. But what was this wonderful thing which I beheld? The scent was already changed, and it was no small change either. A green-blue liquid foamed and fumed over the scent and over the table. The air in the neighborhood of the performance became colored dark red. A great colored cloud arose. This was disagreeable and suffocating. How should I stop this? I tried to get rid of the objectionable mess by picking it up and throwing it out of the window. I learned another fact. Nitric acid not only acts upon copper, but it acts upon fingers. The pain led to another unpremeditated experiment. I drew my fingers across my trousers, and another fact was discovered. Nitric acid acts upon trousers. Taking everything into consideration, that was the most impressive experiment and relatively probably most costly experiment I have ever performed. It was a revelation to me. It resulted in a desire on my part to learn more about that remarkable kind of action. Plainly, the only way to learn about it was to see its results, to experiment, and to work in a laboratory. And the reason why some of the jargon or the words that he used were a little bit weird for modern speakers is that this was written around about 1910. All right, so I have a little media clip that illustrates what this action was that he was describing. So we have a bottle of nitric acid. It's a clear, colorless, kind of viscous fluid, and a copper scrubby. So we're going to put the nitric acid into the flask and then drop the copper scrubby into it. And you can see immediately that we got a lot of that foaming that he was talking about. We have that red cloud, red smoke that's being given off. This is what makes smog burn your eyes. And then if you were able to put your hand up against the bottom of the flask, you would feel that it's really, really hot. So we're going to kind of wait for the reaction to subside a little bit. We can see that the solution has gone from clear to kind of a dark green color. And so once the reaction has stopped, the person in the video is going to add some water to it so they can see what's going on in the flask a little bit more easily, because it's really dark now. And so they pour in some water. And we can see that our clear solution that we started out with is now this really pretty blue color. And this sky blue color is characteristic of what happens when you take electrons away from copper. It goes from looking like copper metal to this blue solution of copper ions. All right, so the next part, we have the mole is holding a sign that says curiosity has rules. So curiosity is essential in science, but it also has rules. Chemistry involves real substances, real reactions, and real risks. Doing science well means being curious and being responsible. So I have a picture here from, it's called Safety in the Lab, and we have people that are pretty much doing everything wrong. And typically, I've used this picture a number of different ways. I've had people list how many safety violations they see. I've had people get up to about 22. I have a puzzle that I've put together where the different safety violations are numbered, and then you have to figure out what the words are that go with it. So we're just going to kind of go over these overall. The number one thing, you have to ask yourself, what is everybody doing wrong in this picture? Hopefully you said something along the lines that they are not wearing their goggles. So that's the number one safety violation. All right, so the second one that I identified, there's no real reason to order behind these, is we have some equipment set up in the lab. We have weights that are suspended. And so the problem here is you don't want to leave stuff set up and then not paying attention to it, because it could fall, it could break something, somebody could get hurt. Now we have number 3, and the issue here is that the young man is pouring stuff into a burette over his head. Now the problem with that would be that if he was pouring something that could damage his eyes, he's not wearing goggles, it could get spilled really easily. And I've seen this one happen a number of times. If you want to pour something, want to fill something up, you take it out of its clamps, you bring it down to eye level so that you can see what you're doing. Down here, number 4, it's the number kind of covered it up, but we have a bottle of orange juice down here at the bottom, sitting right next to a bottle of sulfuric acid. So you don't want to have food and drink in the lab, because you don't want to risk ingesting something you shouldn't. Number 5 refers to this person who is carrying a box. The box is so big they can't see where they're going, so they're likely to bump into somebody or bump into some equipment, break things, stuff gets spilled. We have a bunch of boxes up against the door. Don't want to do that, because if a fire starts out, you want to be able to get out. You don't want to have that door blocked. Here we have what the student is trying to do is they are trying to find out what this odor of the contents of that flask is. And so My sense of smell has been badly damaged by accidental exposures to a lot of really stinky stuff. So you want to make sure that you remember to waft the odors towards your face so that if it's really strong, you're just getting a little bit of it and you're not getting a lot of it. You have number 8, which is down here. This flame thing is called a Bunsen burner. You do not want to leave them running by themselves because every now and then they go crazy. I've seen them get tipped over and then they set everything nearby on fire. This was when I was working in a lab, not my chemistry classroom. So you never leave Bunsen burners unattended. Then we have this girl. Again, the number is kind of blocking what it's doing. She is kneeling on the stool by the bench. You can either stand or you can sit, but you shouldn't kneel because now you have made yourself kind of, your balance is uncertain. All right, 10. I call this girl Susie. Little Susie's having a really bad day because she has not tied her hair back. She's got a Bunsen burner that has been a lit Bunsen burner right next to her, and it looks like her hair is just getting ready to fall into it. Burning hair smells awful. It is frightening if you accidentally set your hair on fire. Please don't do that. We got the stool is sticking out, and so this would be a tripping hazard. You want to make sure your chairs and everything are all pushed in and out of the way. This is particularly important if you have a bunch of book bags in the room, because I've seen several people trip over other students' book bags. You got a spill on the floor, so you want to make sure you clean that up or notify your teacher that things need to be cleaned up. All right, number 13. I've had a lot of students look at that and say, well, they can't possibly be trying to stick a screwdriver into an outlet. That is exactly what that particular person is trying to do. It didn't happen to me, but apparently I had a teacher friend say that she had a student who thought ahead of time they had plastic forceps to protect their hands, and they brought a wire into school and they stuck a wire, one end of the wire into one side of the outlet, the other end into the wire, and the other side of the outlet just to see what would happen. What happened was that there was a big bang, there's a lot of smoke, lights went out in the building, and I'm sure that student got in a lot of trouble. So number 14, it's referring to the teacher. Now the teacher also has to be paying attention. It's not just students that need to be paying attention to what's going on. The teacher should be paying attention. So if you see the teacher's attention kind of wandered off, not paying attention, and you see something bad's going to happen, let them know what's going on. We got 15. We have glassware sitting on the edge of the bench. I always tell my students glassware is suicidal. If you get it anywhere near the bench, it will fall off. So make sure that you keep your equipment away from the edge of the bench. 16, took me a long time to figure out what this kid was doing. I knew it was something bad. I finally had someone explain it to me. They're getting ready to shoot a hornet. I don't know what they're called in South Dakota. That's what they were called in North Carolina, where I got this picture from. What a hornet is you take a staple and you poke it through so that the prongs are sticking out. You poke it through a piece of paper. Fold the paper over so you can shoot it with a rubber band. And then when it hits somebody, the prongs of the staple make it feel like you've gotten stung. So that would be no horseplay. And then 17, I don't remember what that one was. And I've already got the circle on top of it, so I can't remember. We got 18. It's referring to this test tube, which is pointed towards little Susie, who is having a bad day. Now, the thing with test tubes is the glass inside the test tube is really, really smooth. And so liquids, water, sometimes have trouble forming bubbles when they get hot enough so they can start boiling. So instead of boiling, they will superheat, and as soon as you get a bump or it just finally hits that point where it can't superheat any longer, it goes blasting out of the test tube, and it's going to hit Susie in the head. So like I said, she's having a bad day. And you got 19. You don't normally see this one in like high school chemistry labs. These are a bunch of gas tanks that are just standing there. You want to make sure that if you are working with them, say you get a job after high school, they need to be strapped and chained so that they can't fall over. Because if they fall over and the neck on the gas tank gets broken off, they take off like a torpedo. And they're very, very dangerous. And then 20 is referring to back to the kid number 3. So he's pouring stuff into the burette, but he hasn't made sure his equipment is set up properly because the valve on the bottom is just letting it dump into the flask. And so he's going to keep pouring and pouring, pouring, and it's going to end up being spilled all over the place. All right, so that was it for the safe science picture. So coming soon in subsequent lessons, we are going to be doing real experiments. We're going to measure how much heat is given off by different reactions. We're going to be separating mixtures. I love doing labs, but of course the key to being able to do the labs is to be able to do them safely. We're going to be solving puzzles by using the little bits of evidence, the data that we collect, in order to figure things out. We're going to be looking at different reactions and see what happens when you do that. There is a lab where we're going to combine, it's like 50 different possible combinations, and then we're going to see all kinds of pretty colors and precipitates forming. And then hopefully once you have enough of a foundation, you'll be able to start asking your own questions about why something happened, what exactly happened, how did it happen, and when will it happen again. All right, so that's it for this very first lesson of this semester. Thanks for listening.